they should all be there. It's just IMAUG YouTube. You should be able to find us. Our meeting last week was there. If you have any questions, feel free always to reach out to any one of us organizers, and we'll do our best to figure out if we can't help you personally, forward it to somebody who can, or figure out how to solve your guys' problems. Our schedule right now, today, we are going to have Serverless Enterprise Applications by Matt. Our next one will be Application Monitoring, which will be kind of a part 2. And then we'll be doing a Power BI one starting January. And we do have there's some free resources out there for Azure Learning, Microsoft Learn, Pluralsight, and the cloud training. And this meeting, we are sponsored by Sogeti. And I'm going to hand it over to Matt for the sponsorship and talk. Just a little background. Matt has an extensive background in software development, building enterprise applications for businesses in finance, insurance, government, healthcare, and real estate. So Matt, I will hand it off to you. Oh, sorry. And we will be doing a drawing at the end. So at the very end, we'll draw some prizes with the spinning wheel. So make sure you stick around till the end to be entered into that.
Thank you, Alec. So I didn't prepare Sogeti is the sponsor for this, and I didn't prepare the elevator pitch for Sogeti. So I'll make it really quick. Sogeti is consulting services, part of Capgemini. We are the technology and engineering arm of Capgemini, international in 35, 38 countries, 24, 25 offices in the U.S., most major cities covered in the U.S. Part of our footprint is to maintain a local feel, but have a deep global reach, and that's why we have offices spread out throughout the world. There was a PowerPoint I could have done better justice to Sogeti Capgemini, but I did not prepare for that, so I'll leave it at that. Now I'm going to share my screen. Oh, we will be raffling off 2 prizes at the end of the meeting to whoever's left, and you can't be from Sogeti. Sorry, guys. Share my PowerPoint. So I'm going to be swapping back and forth between 2 different computers, so bear with me here as I do that. Okay. Serverless apps in Azure. So the concept for this started a few years ago. I started dabbling in Azure like a lot of people 3 or 4 years ago when it started to pick up, and then like everybody, you create some VMs, maybe an app service, some networking. Yeah, that's cool. I can put a VM in Azure, but where's the value add, right? Then you start to see things like function and the serverless compute, logic apps, those types of things started coming out, and all of a sudden things started clicking. Oh, this is a whole different way of thinking. This is a whole different way of architecting software. It's a whole different way of delivering, maintaining, and running systems, right? Special thanks here to contributing from Brandon Sharp. Brandon Sharp helped with some of the Azure DevOps stuff, some OAuth, some API Gateway. Corey Gideon helped with application insights. Robert Duvall helped with code and the pipeline, CI/CD pipelines. And Rob Haley and Shashank also helped with SQL database and some of the code. So we started this project as a way for our own consultants to start to learn Azure, and not just Azure, but the serverless offerings, the low code, no code, the cloud native concepts that Azure has. So as I go through this presentation, feel free to ask questions in the chat. I'll try to respond as time allows. The serverless is quite a huge concept. It's a large topic that probably warrants a few sessions like this. So my focus is really going to be on the core serverless offerings of Azure that help create a enterprise web application. So we're not going to go into detail on things like Kubernetes. I think that warrants its own session, and I think we have one on the agenda for that coming up. So I'll just preface everything with that. So what is serverless, right? Does this mean there's no servers? Well, no, obviously no, there's servers somewhere, right? We have Azure data center, there's going to be servers. But what it means is all these buzzwords that we hear: infrastructure as a service, platform as a service, function as a service, backend as a service. It's obfuscating the hardware away from the application layer, right? So as a business, as an organization, I can deliver software to my users without needing servers, without needing infrastructure, without needing to understand necessarily what's going on behind the scenes, whether it's, maybe there's some Linux servers with some containers and some fancy Kubernetes going on behind the scenes, but ultimately, I don't need to know about that. I don't need to worry about that. That's not part of my concern. Azure handles that for me. The cloud provider handles that obfuscation and that scaling for me. So what are the advantages of that? So when you eliminate your infrastructure, you eliminate your VMware or whatever your virtualization provider is, you lower your maintenance. You start to not worry about patches and upgrades of servers, of environments, operating costs from having a data center, right? Not just labor, but the cost of the hardware, of replacing things, of the building, the plant costs. Reducing time to market, decreasing lead time are two of what I see major benefits of this no-code, low-code, serverless, cloud-native platform, in that it allows developers and product owners or business users to focus on the software that they need to deliver their product, right? And that's it. It really aids in the DevOps principles. So you're basically only concerned about your application. You know that your platform is already built out for you, that it will scale for you. So you focus on building the software, not the infrastructure, not the handoffs, not the constraints of operations. Although, operations is still part of it, right? The other thing is you only pay for what you use. In a serverless environment, especially with what Azure has to offer, the costs are greatly simplified, and it's easy to see, and I'll show you that when I demo this application that we put together. It's easy to see the costs that you're incurring from the specific application that you're delivering. So within your application stack, all of the resources that are part of that application, it's easy to see the costs associated with that, which then allows the chargebacks to that particular business unit or value stream or product area or whatever it is. The scaling, the redundancy built in, right? So out of the box, you have auto scaling, redundancy. There are different levels of redundancy. You can get into more advanced redundancy with geo and multi-zone. And then again, the low code, no code, it just simplifies your development process. It shortens your dev cycle. It caters to agile principles. It allows DevOps to happen. It really makes it makes the dream of DevOps and the true agile tenets come to life. And then the monitoring is built in. Application Insights is a great tool in Azure that gives you direct line into code that's running in production, and you can see real time what's happening, where you're getting an error, what that error is, where it's at in the code stack, how long it's taking to run, and then the security, obviously, too, with either Azure AD or role-based authentication, and whatever your security needs. There are multiple options with the serverless platform. My cat is meowing in the background, and I'm not sure what he wants. So here are some of the serverless resources that Azure has currently, and some of this is old. The ones that I'm going to kind of dial in on and focus more on will be the storage account, the Azure Storage, the Azure Functions, the Logic Apps, and the Azure SQL databases, and Service Bus, Event Grid. So the main constituent pieces of building out an Azure serverless enterprise app are really these things here. So the Azure functions are really crucial to having a consumption-based pricing model, kind of a pay-as-you-go. And then the logic apps tie into that, and the event grid, event hub, service bus, those message queuing systems are what make it possible to truly make this enterprise, and to offload processing, and to really give you resilience. So functions in of themselves aren't robust enough on their own to be considered necessarily an enterprise grade delivery platform. But when you combine them with the event grid, the event hub, and the service bus, and logic apps, and different types of triggers that you have and then with Cosmos DB, with your document database or NoSQL databases, then you start to have all of the things and all of the pieces of the puzzle that you really need to create that enterprise level application, and go into even into a hybrid model where you may have some on-prem systems that you're trying to support, as well as some new stuff that you're putting into Azure, and you need those things to talk to each other, or you're working with third-party vendors, you have other APIs you need to call, you have other systems that you don't support, that you're relying on, then all of these pieces come into play to help that mesh together. So,
hey Matt, was there a reason you chose a event queue or event grid instead of a storage bus?
So this is the image I could find, and I have another image later that shows event grid, service bus, and event hub, and kind of explains the difference between the three. Is that where you're going with that, or?
Yeah, I didn't know if a specific application you were creating, if you chose event grid versus service bus.
Oh yeah, well, I'm going to get to that in another slide here.
Okay, thanks.
Good question, because that's sometimes confusing. So the most important aspect, and the thing that we focused in on the most, is probably the functions, because most of us are developers by trade, and that's our background. So trying to figure out, what can we do with functions? How far can we take functions? Are they good enough to do everything, right? Can we do it all with functions? So on Azure, this concept of functions. You have functions as a service. There are different types of triggers. So the basic trigger that we use the most is just a standard HTTP trigger, which what that does is it allows you to expose a function via a REST API. So it's callable over standard REST protocol. So you can hit it with Postman, you can hit it from a Angular front end, React, iOS app, Android app, web app, Blazor, whatever you want. The other concept is to have a timer. So your functions are a small piece of code that would execute on a schedule, right? And that's more practical or applicable for offline batch processing activities, not necessarily supporting a web front end. And then Cosmos DB can trigger firing of a function based on data coming in, data writes, reads. The blob storage, you could trigger a function to happen when data gets written to a blob storage, either a file or table storage in the Azure storage accounts. And queue storage, so the event grid, when event grid fires, it looks like I spelled hub wrong there. Event grid, event hub, and service bus all also have the ability to trigger Azure functions. So Azure functions can be written in, right now these are the supported languages. For our purposes, we were using C#, but you can use JavaScript, F#, Java, Python, TypeScript, PowerShell, and there may be support for other languages coming. And then as far as pricing options go, the basic kind of the serverless compute concept is the consumption plan, where you pay per usage, right? And that gives you so much. That gives you a certain number of free transactions. It also gives you a certain number of CPU along with memory. If you need a higher performance level, you have a higher demand load, you can go to the premium plan, which gives you a little bit better performance and higher throughput. And then ultimately, if you need a dedicated plan, you can also do your own app service plan, where it functions the same as an app service plan, and your functions just reside inside the app service plan. In that case, your pricing works just like the apps. You're paying for the app service plan, right? So if you have a super high demand and you have a high performance, then you would want to go more towards the app service plan model. And Derek, correct me if I'm wrong on any of this, because you're the Microsoft guy, so you might know more where we're at than I do at this point. So here's just a little bit I pulled off of Azure's pricing for the current pricing on functions. This kind of shows you that for a normal, moderate enterprise, few hundred users, maybe thousands of transactions a day, your costs are very low, if almost zero on functions, right? I mean, 400,000. If your functions are running literally in under a second, I mean, if they're fast, if they're optimized and architected for this in a microservices strategy, your costs are very low and negligible. When you get to the point where you're running hundreds of thousands of transactions a day, then you need to step it up. You need to go into the premium plan or the app service plan. But if you've architected your functions in a way and your application in a way that they are quick hits, milliseconds to run, they do what they need to do, get their return, you can basically run this for free. Now, you still pay for storage, and there's some caveats there, where you're still gonna have to pay for the storage accounts, the SQL databases, the Cosmos database, the blob storage that you will still pay for. So messaging services, when to choose. So we have these three concepts of event hubs, event grids, and service bus, right? So event hubs are more for big data, for AI stuff, right? Where you've got a bunch of sensors that are writing events, millions of events, lots of data. That's where event hubs come in. Event grid is similar. You're writing events though, not messages. So when you get to an enterprise application where you want to offload a long-running process because you don't want functions to run more than a couple minutes, the concept of functions is to not be a long-running process. You want it to be short. If you're finding that you have longer running processes, or you're calling out to external systems or other APIs outside of your application, then you want to leverage something like the service bus, where you would put the message on the bus, and then you subscribe to the response. When the response comes back, then your response function would fire. So service bus more for, I guess in our experience, more for this transactional system of record data entry systems that we see a lot of in our line of work. The service bus comes into play more. And event hub, event grid are more for, you see that more in AI and sensors. And then SQL Server is a big part of these applications as well. And we focus in on SQL Server. We did have some debate back and forth between whether to use a NoSQL database, Cosmos DB, or to go with a relational model like SQL. We landed on SQL. And in Azure, there's three main ways to do SQL. You can either create a VM, right, and spin up SQL Server on the VM. That's the old way. That's the path we know, right? The other option is to do the concept of this Azure SQL managed instance, and the managed instance they're really for, you're trying to get to cloud, you have an on-prem database, you want to get it to Azure. This is a way to do that. This gives you pretty much apples to apples functionality, what you have on-prem in Azure. But if you are creating a new database, a new system, the preferred way to go would be to create the Azure SQL database. So in the Azure SQL database, in the third option here, that's where you have the option to do a consumption-based plan where you pay as you go. So in a lot of cases, you see these 9-to-5 systems that are really only up 9 to 5 or 7 to 5 or whatever, right, during business users hours. And in those scenarios, for production, it makes a lot of sense to have the concept of the serverless SQL database, where it's pay as you go, right? You're only getting charged when the thing is running. I will say we did run into some issues where not a good idea to use that for development or testing, because what we found is during the development phase, that database was up all the time because the shutdown time is 1 hour after activity stops, right? So if you have developers or testing going on, you can see how you're inevitably going to be using that thing all day, right? So for dev and test or staging or UAT, what we found is that just the basic SQL instance actually proved to be more affordable than the serverless compute instance. But in a production situation where you're only operating from 7 to 5, it makes a lot of sense to go with that option. So here is a reference architecture that we just pulled from one of Microsoft's, one of their online books, actually. And I think there's a bunch of these about microservices and different architectures in Azure and serverless. So the concept here is it's a basic web application. You have a single page web application front end, so that's something like Angular, right? SPA app on the front. And that's hosted in the static website hosting in Azure Storage. You can use the CDN to get you to help with the caching of static content, especially if you're geo distributed across the world. And then you use an API gateway to manage the calls between the SPA front end and the back end functions, which is essentially your API layer. And then the functions would read write to your data layer. In this particular diagram, it's using Cosmos DB as the data. Like I said, we're using SQL Server, not Cosmos. And then you can use Azure Active Directory or the RBAC and the OAuth mechanisms that are built into Azure to provide your authentication, or whatever OAuth provider you want, really. There are multiple supported OAuth providers. This I just threw in here as just an example that I found of a microservices approach where you have functions calling functions. So you have there's a web trigger that this particular is like a shopping cart, right? And when you check out, it writes the data to the database. And then this is all asynchronous happening behind that. There's a trigger on the database that does the rest of the processing. So it's just kind of showing how you can chain functions together to create a full enterprise application. Here's another one. This calls out the B2C Azure Active Directory, or you can actually have consumers log in through AD and use role-based authentication. And then they have broken this app out into a driver API, trip API, and passenger API. So that's kind of, again, that microservices approach where you're separating boundaries, separating concerns, separating domains. And then they do have this durable trip manager monitor here. So there's this concept of durable functions for longer running processes. So durable functions have a few other options outside of regular functions. I'm not going to get into real much detail here, but you can do the basic runtime for functions is limited to, I believe, 5 minutes last I checked. So if you had a process that was running more than 5 minutes, your function would time out. It would stop. But the whole concept of functions is to not use them for long-running services. So you want to try and architect out of that pattern, right? So here's a hybrid architecture. So if you want to use a combination of Azure and on-prem, you have the ability to run your functions inside an app service plan, would have access to a VNet, or also in the premium plan, the functions would have access to a VNet in Azure. And then that VNet in Azure could have a site-to-site VPN, point-to-point, between that Azure VNet and your on-prem network. You could also use ExpressRoute for this. But this is one strategy to have to integrate the hybrid model, where you have built out systems in Azure but you also have on-prem systems that you need to talk to, that you might need to send data to or get data from in order to run your Azure functions or systems. And the one thing that this diagram is missing is that you would ideally you'd want an API gateway in between these, so that you're at least front-ending your API calls through some kind of gateway, whether it's on-prem or in Azure, and orchestrating your calls that way rather than just having functions directly talk to on-prem services. So here's another example of a microservices architecture. And the reason why I put this in here is because of the next slide. So this is, if you think about what you can do with functions in microservices architecture, it's a way to slowly reduce or replace monoliths. If you look at it like this, where you may have an old application where you move that app to like a one-to-one to Azure to an app service plan. So you have an old .NET application and you just move it to a Azure app service plan. Well, you can continue to use it and architect around it, similar to what this is trying to portray, is that you start to break out some of that functionality into new services while you're still using that old API. Logic apps is another big part of the serverless offering in Azure, and I like, I'm not going to cover, like I said, there's a lot of topics in serverless, and this probably warrants its own meetup. But the thing I like about Logic apps, and what Microsoft has done a really good job at, is being able to easily visualize a workflow and create an orchestration using all of these tools right in the Azure portal. I won't go as far to say it's so easy that a business user can do it, because we've been saying that since I think Microsoft Access came out. But this really it's very robust. There's a lot you can do here. Calling out to functions from Logic apps, or functions calling Logic apps, and then creating this kind of top-down procedure flow or orchestration of events. There's a ton you can do here. And this next slide kind of depicts what that looks like, right? You're just, it's kind of a drag and drop. You create it in order with decisions. This shows a condition. You can write code in here. You can call out to a function and then have the response from the function come back, and then have a condition or a decision based on that and go to the next thing. And then this ties in with all of the Microsoft products that are in Azure, with SharePoint, with the Power Apps, Power BI, it ties into everything. Very powerful. And this shows you just an illustration of how the conditions work. It's very easy. Okay, transition a little bit into Azure DevOps here, just to show an example of an Azure DevOps workflow and CI/CD pipeline that could be used for these types of applications. And for that matter, I mean, you can use this for any application, right? But for our demonstration of the app that we wrote, we have, I'm going to show that, 3 repos. We have a spa, yeah, we have a spa app repo, and 2 API repos that are functions, and they all have their own CI/CD pipeline, release, continuous integration, continuous deployment, and automatically get released with the deployment slots. Then ideally, in the real world, you would also have a project for your data, SQL Server, either a DAC pack, or maybe you're doing a code first model, but you would want to also automate the release and the SQL database part of it. Okay, so time to walk through some code, show you the example. So I'm going to share my other screen. Okay, so we created, and this is by no means complete and done. This is mostly a prototype, proof of concept. Still lots of to-dos. Please don't judge us. We have this is Azure DevOps for those of you who haven't seen it. So we have full Git repos and CI/CD pipelines and everything built in here. So we have the SPA app, which is a Angular UI, SPA front end. And then we have a user API behind that, which that's a function app. And then we also have a admin API behind that, which is also a function app. And so those are our main three projects. We created CI/CD pipelines for that, and Azure DevOps. And I'll just dial into one of these, admin API. So it's .NET Core. So you can see it's .NET Core 3.1. It's a function project. And if I go to Visual Studio here on my machine, the code footprint on these is very minimal. We have a SQL database behind this, and the function project is just it's simple CRUD operations with very little business logic to and from that database. Of course, if you wanted to do some business logic, you could add a layer in here for that, or another function for that, another API layer for that. But the amount of code that we had to write to do this was very trivial and very low. So here's an example of just one function. So the use case for this application was, let's create a SurveyMonkey app. Let's create the concept of SurveyMonkey, where this system will allow you to create surveys, add new surveys or questionnaires, and then allow them to be responded to and keep track of all that. So that's the basic use case concept for this application. So the database has things like surveys, questions, answers. I can show you the database. The database is much larger than we use it for, obviously, because it was proof of concept. So we have questionnaires, respondents, responses, types of questions, that kind of thing. So it's just a standard SQL database. And the function, there's an admin function app, and then there's a user function app. So one of the APIs is for creating surveys, creating questions, and administering surveys, and then the other API is for the UI that you actually use to fill in the survey and answer and respond to the surveys. So just to show you real quick how the pipelines are working, I'm going to change the verbiage here on one of our functions. And I'll do a commit. Make sure I'm on the right repo here. Push it. And then if I go back to that pipeline, you'll see that should be running. Yep, so the pipeline, that my push initiated the pipeline to run. Once that pipeline runs, it will trigger the continuous deployment, which will initiate the release to the Azure resource. So I'm going to go into the releases here. And I did this earlier today just to make sure it worked. So if I go in and edit this, you can see on this release, when I go to tasks, it's deploying an Azure function to my subscription, to this app, to this resource group, to this deployment slot. So I have a kind of a blue-green deployment. So once it gets deployed to that slot, then I can test it with Postman or run some smoke tests, make sure everything's good, and then swap the blue slot with production, and I'm rolling in production. You could also automate that with an email or a text message or whatever you choose to do. So that is an example of how that process works. Let's go back and check our pipeline. Still running. Sometimes this takes a while. And there was an outage in our, yeah, that might be a problem. So ultimately what gets deployed is this application. And I'm going to send this out to everybody here in a second. Okay, so when I send this out, I'll send this link to everybody here in a minute because I want to show you something before we get to that. Click on this drop-down list. Please select the Iowa Azure Users Group. If you could select any of these, if you want, it's not going to break. It's just I would prefer that you selected Iowa Azure Users Group and then answer these questions. And then scroll down, click Submit Your Response. It may take a few seconds. you'll see a green bar up at the top that says your response has been submitted successfully. So what I'm hoping to see after that is to go back into the Azure portal, and in Application Insights for my functions, I should be able to see the activity that's happening. So that's another advantage of this that we mentioned earlier on these serverless applications, is that the application monitoring is sort of cooked in, and it's very simple, very trivial to implement. While we're waiting on that, I'm going to go show you the resources. So these are, when I create the SQL database, the functions, and the static web hosting resources in Azure, these are all of the things that get created. So when you create a function app, whether it's consumption-based or premium or part of an app service plan, it's going to, behind the scenes, create an app service plan regardless. So don't get concerned with that. That's fundamentally how it works. It does have an app service plan behind it, but it's still a consumption-based pricing model. So you're not actually paying for an app service plan. So when I created this Sogeti serverless demo function app, it created the app service plan behind it, and it also created a storage account behind it. So the storage account is necessary to store the files that are part of the code that you wrote. The app service plan is necessary as part of spinning up the function, right? So every time you create a function app, even if it's consumption and serverless, you're still going to see behind that an app service plan and a storage account. Then the SQL database, this is also a point of confusion with a lot of people. When you create a SQL database, it creates a SQL server resource behind that. It's just part of the backend that's required in order to spin up these resources. And then the other resource here is this questionnaire static host. So this is truly a blob storage account that is doing the static website hosting. So you can put your SPA app directly into the storage account and target it directly from a URL. And the cost on this, all you're paying for is the storage. So it's very low cost. There we go. So you see there's the static website is part of this storage account. And it gives me a URL as an endpoint. And inside here, we have two containers, one's for logs and one's web. Inside this web container is the Angular SPA application. So when you hit that endpoint, you're hitting this Angular SPA app. I'm going to go back. As part of cooked into Azure Functions, you have Application Insights.
Hey, Matt.
Yeah.
Have you noticed any delays with hitting your static site and then hitting a backend, since Azure functions sometimes spin up?
Yes. Yeah, there is a cold start, about 3 seconds ish on the basic plan for functions and the static website for that matter. If you don't like that, you need to go with an app service plan or durable functions.
Okay.
Yeah, that is true. There are ways to mitigate that. Run a script to hit the site in the morning before you know people are going to come to it. Run some automated tests on your APIs before before the day starts, that kind of thing. Yeah, that's one way to mitigate it. Where was I? Tags. Okay, so I'm going back to it. So, like I said, one of the advantages of the functions is the application insights being put in. So when I click on when I go to this function resource in the Azure portal, I can go directly to application insights here. And dial right in on the metrics for that function. So I can see how many times it's getting hit, if I'm getting errors, if it's failing, and then I can even dial in. And then when I click on those, I can dial in even further, and I can actually see the HTTP payload. I can see the posts back and forth. I can see what methods are being called and whether or not they're successful. So right now you see there's nothing showing up for this function in the last hour. When I send you guys this link, I'm hoping that you all hit it and we'll see some activity. So I'm going to do that. What happened to the screen?
If you go to chat, Matt, you should be able to see the meetings chat in there.
I think I found it. Okay. I had to stop sharing in order to see it. Okay, there you go. Can you hear me? Did I lose you guys for a second?
I can hear you.
Okay.
Yep.
So we're already starting to see some requests coming in on this function API. And if I drill in on these requests, can you guys see my screen?
Yeah, we can.
What do you see right now?
Your app insights
Okay.
in Edge, I think, or Chrome maybe.
Okay, so yeah, if I click in on these server requests, I should be able to see what's getting hit. So get all surveys, get questions. Those are two methods that to populate. So that drop down getting populated is the get all surveys, and then once you click on the survey, it's telling get questions for that survey. So we're seeing actual live our methods and our function getting hit. It's telling us how long it take, how many times it's getting hit. This is pretty awesome stuff for a developer, for a sysadmin for that matter. If you get an error, you can drill in and you can actually see the data potentially if you needed to. So then if I go to the other function, we should be able to see. Oh, not too far. Oh my God. Forget it. I'll go back to this one. So the other function app was this one. But application sites. Plus. Oh, that's the same one. No, not that one. So, I got 36 requests on this. So this method, I can see this has been called 197 times. This is the actual method that is going to take the results or take your answers and insert them into the database. So if I go to the database, I had 780 answers in that table. If I run this again, I should see now I have 912. So now let's look at the costs. So since I started this thing up to make sure it's all working yesterday, I think, and we'd already built it out before that. So far this month, it's cost me $4.40, and most of that is just the SQL database. Actually, I would say all of that is the SQL. Yeah, all of that is the SQL database. So you can see, and let me refresh just to see if our recent activity impacts this, which it should not. Unless you guys hit F5, hold down F5 key a million times. This should not change much. So essentially, the brunt of my costs for the month are just the data behind that SQL database. That's see, you can easily run now. Even adding in the OAuth and even adding in the API gateway, you're still not going to see these costs increase on a low volume enterprise app like this, where you have maybe a few hundred users, a few thousand transactions a day, system of record, data entry. The costs are trivial on this. Now, when you start to get into storage of that data, reporting on that data, data warehousing, analytics, then your costs start to increase. You start to get into thousands of users, millions of hits, then the costs start to go, or tens to hundreds of thousands of hits. Then you need to upgrade to the premium plan, and then you need to get into the app service plan, and then you start to look at the bigger pieces. But for most of these data entry style systems, where you've got 20, 50, a department, right, doing some data entry, system of record, some reporting, SQL database, the costs are very low. Go back to my other screen. Okay, so that's kind of the end of the demo that I wanted to give you guys. Are there any questions at this point before we move on? So the next area I wanted to focus in on was the application insights and monitoring, and that really is a whole meetup presentation in of itself. So I'm going to save that for next time, and Corey Gideon is going to present on that, but just some highlights here. Overview of app insights in Azure. So final thoughts. The few things that we have yet to add to this to be able to demo is the API gateway. Part of an enterprise app is having that API gateway orchestration layer. So that's something you definitely would want to consider. The CDN for static site, static pages, especially with geographically distributed user bases, and the Redis caching would come into play with that as well. Possibly adding the concept of Cosmos DB and NoSQL. as opposed to the transactional relational model with SQL Server. Then OAuth using Azure B2C, the RBAC, the authentication security model. Of course, for this demo, we did not, everything was not infrastructure as code. That would be in a real world situation, you would want everything to be infrastructure as code so that it could be spun down and spun up on demand, especially the SQL database, which we did not show that. And then we would want to implement the Sonar, some kind of vulnerability scanning in our pipelines, automated testing in our pipelines using the Azure test plans, automated postman tests of our API, some logic quality gates in the pipeline that maybe send emails or text messages or some kind of a final check approval from a human. Concept of canary releases or blue-green, how would that play out in a real world environment? How would you do that, right? What would that technically look like? How would you distribute the application between a large user base so that you could, in the wild, actually do that? That's kind of a next step we would like to play with. And then final thoughts, what are some disadvantages of the serverless? So I didn't say, I did say at the beginning that I wasn't going to cover Kubernetes because that's a whole separate topic in of itself. Kubernetes has the ability to fill in a lot of the gaps and issues that we have in serverless. Performance, any cold start stuff, performance stuff, some of the long-running issues. Kubernetes solves some of those problems. It creates its own problems, though. It's a beast, right? Vendor lock-in. A lot of people are worried about vendor lock-in. I am not one of those people. I know Derek's not, but it's a valid concern. But the Azure Function Platform is perfectly portable. That could run on other cloud providers. It can even run on-prem if you need to. But whenever I hear the vendor lock-in argument or fear, I just think of what we went through in the 90s with Oracle and SQL Server and Java versus .NET, and how none of that ever really played out in the real world for most people. It did. There's some situations where companies did port from Oracle to SQL Server and vice versa, and there's situations where companies ported from Java to .NET and vice versa, but it's very few and far in between, and I just don't think it's, for most people, I don't think it's a concern. It does require re-architecting or rethinking your systems with more of a microservices strategy in mind. Sometimes things have to be rebuilt. It just has to. Some of those old monoliths that we built in the 90s are just, it's time for them to go. And the other thing is it can cost more. So you have to be careful if it is a high volume situation and you do have a lot of users and you do have a lot of transactions, it might not make sense. You may be better off going AKS and dedicated SQL servers, or I mean, even in some cases, virtual machines. If you have special niche skill or niche needs and high volume, you definitely are going to need dedicated resources anyway, to the point where choosing the consumption-based plan actually could lead to higher costs. So that's it. That's all I got. On time. questions, comments?
So I put it in the chat window just now, Matt. There's actually a new capability that has been developed to be able to take, if you've got a current API currently using like Swagger, there's a Visual Studio's Code extension that can actually take the API and stub out your Azure Functions interface for it. And all you have to do is port the logic over to it. So if you want to take a current API you have and set it up in Azure Functions to utilize the benefits of them, there's a migration path that hopefully will make it a little easier.
Nice. What was that called? Or
it's a Visual Studio's Code extension. So I put a link to it in the chat window. It's something that just came out.
Gotcha. Yeah, nice. Thanks. Well, one other thing I don't think I mentioned is also trying to tie in a service bus to this would be a next step as well for a long-running process or an external dependency or a third-party system that you have to call out to. Lots more to do. Lots of cool stuff coming. Any other questions? Quite a few people on. So,
Yeah.
Go ahead.
I'll say if that's it, I think we'll go ahead and wrap it up and go to the drawing.
Spin the wheel.
Spin the wheel.
So Sogeti has offered to give 2 prizes away. The prizes have not been announced yet, but they will be something similar or like a Amazon 4K Fire Stick or Roku 4K stick or Amazon Alexa wall clock or Amazon Alexa in your car thing. I don't know what those are called exactly, but it's a way to get Alexa in your car essentially. So
We'll go ahead and spin the wheel, and then whoever wins, you have 2 winners, right, Matt?
2 winners, yeah.
Maybe they can reach out to you.
Whoever wins, we could
figure it out.
Yeah, give Alec your address and we'll ship the prize to you. Pete, congrats.
That's the first one. Remove and go again.
Damn.
And Dan Anderson.
Congrats.
Go. So if you guys just want to send me an email, I can pull that slide up again real quick, and we'll coordinate getting you whichever of those. If you want to reach out to either me or Matt.
Yeah, just send me or Alec or both an email. We'll need your address and we'll ship the prize. So congratulations. Thank you.
Thanks everybody for coming. Thank you, Matt, for giving that talk. We look forward to the second part on the 15th, where Sogeti will be sponsoring that one as well. And we'll see y'all then.
Yeah, thank you, everyone. So
Thanks,
next time will be a continuation of this, and we may follow up on a few of these topics, but Corey Gideon is going to talk more about monitoring and application insights.
Awesome. Thanks, everyone.